All right. Thanks everyone for coming, and thanks for the invitation to present here. What I'd like to talk about today is how we're going to utilize CAE simulations on the cloud. This can also be applied generally to any kind of HPC CAE type simulation, and also any type of simulation like molecular dynamics and applications like that. Now, to start off, I think the easiest way to kind of get a feel for what we're doing with Rescale and how you can accomplish this is maybe talk a little bit about my background and why we started Rescale. So the story starts about 10 years ago when myself and my co-founder, who was my boss at the time, we were developing the CAE tools and the simulation process for the 787 wing. And so in order to develop the best possible wing design, we had to balance running CFD simulations, fluid dynamics for aerodynamic results, structural simulations, manufacturing simulations, and try to combine these all together. And my background is a mechanical engineer and applied mathematician. I also did a degree in aerospace. And for my thesis, what I developed a lot of tools in academia around is how to solve multidisciplinary problems like this. So at Boeing, what we did was connected all these software tools together, spent about 2.5 years developing our own tools and processes. And we did this all, and this is quite a while ago, so this is on a data center, all on-premise, and we had some very good results in the end. But we also had a lot of challenges. And so in the end, what we were able to accomplish was that we reduced the weight of the wing by about 150 pounds, which saved Boeing over $180 million. And so we knew that if we can solve this problem, we can actually both improve the product, and we're able to run this simulation in about 24 hours, so a brand new composite structural wing in 24 hours, relative to the traditional process, which used hundreds of engineers and took about 3 months. And so this was really kind of a game changer for Boeing. Now, unfortunately, at the time, this was something that probably only about 5 companies in the world could accomplish. And so, fast forward a few years later, essentially, my co-founder and I both left Boeing, went into different directions, but then we joined back up to kind of start this company around the idea of, it'd be really valuable if other people had this same tool and were able to execute on these same type of simulations. And it's not just in aerospace, and like I mentioned, not just specifically fluid dynamics or structural analysis. There's many different verticals that use CAE tools, and there's other tools that have similar computational profiles, and they can all benefit from everything I'm going to talk about. And most importantly, this is something that I think is very underappreciated by people that are not in the CAE or in the HPC space. And so, what I've been doing over the last few years is a little bit evangelizing this with people who are not as familiar with it, to become, a little bit more familiar with the market opportunity. Because in every single one of these verticals shown here, essentially, there's billions of dollars of decisions being made, and in some cases, CAE tools are being used very well, and in some cases, not so well. And in almost all cases, it could be done better. And so what we set out to build is a tool for anybody to use to accomplish the types of results that we were able to accomplish at Boeing. Now, diving one level deeper into kind of CAE tools specifically, there's also a few trends and things happening there. And so a big part we're seeing is a significantly increased complexity of models. So many more cells in fluid dynamics runs, much more detailed designs, and being able to capture all the detailed physics elements within these designs and simulations. Then also going towards kind of multidisciplinary optimization, multidisciplinary types of analysis, which are combining some of these physics-based tools together. And this creates an exponentially larger compute problem. And this becomes especially relevant when you start to loop these things and do big designs of experiment and optimization studies, which is exactly what is so valuable to do for these industries. The other part is that the predictability is changing, right? So I don't know if you know, with Boeing, with 787, that was a project that was about 3 years late. And so within any of these industries, you see a lot of deadlines kind of being missed, and a lot of times these can be due to various factors, but one thing that can really help improve this is virtual prototyping with CAE tools and trying to come up with better kind of predictability on what the design, how it will perform in manufacturing, how it will perform in the actual tests to avoid any kind of delays. And lastly, what we believe is that the current infrastructure and the current way software tools are being deployed is something that's really, it hasn't really changed over the last 20 years or so. And so what we believe is that we can improve the responsiveness for engineering organizations, both on the IT side and on the CAE side. We can improve that significantly towards kind of on-demand, pay-as-you-go type models. And this will help a lot with the flexibility and the ability to respond as an organization towards kind of the changing needs as you go through a design process. And so as you move towards cloud, so everything so far is kind of, on on-premise HPC, this is all the same story. But cloud, has huge benefits. So it can help reduce product development time, so be able to kind of reduce the simulations both through kind of optimal hardware, but also unlimited, essentially, resources for engineering teams if the budget makes sense. It can also result in improved performance. And so this is what I talked about earlier, is by basically utilizing CAE tools better, you can develop much better designs. And there's a huge kind of leverage in this for large enterprises especially. So large aerospace companies, large automotive companies, CAE tools can optimize a few percent savings on a product that's used in aerospace, for example, for 25 years, can result in a huge amount of value for the company. The other part is that the actual engineering costs and the IT costs and the overhead to be able to deliver this are actually reduced. And there's a lot of people who are skeptical about this, but if you really look at it and crunch the numbers on if you run Cloud HPC versus an internal on-premise cluster, there's huge benefits to be had, both in a way of using it for overflow and integrating through a scheduler, or using it for specific projects, but especially for transitioning towards a fully cloud-enabled model. Most importantly for IT, it really improves the agility of the ability to respond to what engineering and scientific teams need. And so for that specific purpose, cloud is basically perfect. There's no procurement time. You can instantly turn on a few servers, and there's no additional kind of hassle and overhead to make sure that you can deploy this in a robust way. It's all taken care of essentially on the back end. So you don't have to worry about that anymore, and that's a huge benefit. And finally, security. This is kind of both a challenge, but also a huge opportunity. So I'll talk a little bit more about it, but we basically have developed a security model that is both meets kind of all the existing requirements that large enterprises have, but also exceeds them in certain ways, because there's a lot more visibility around how data is shared, who's looking at what, and a lot more controls around managing kind of how data and simulations are run within the enterprise, and being able to respond to that when things to do with security happen that you didn't want to happen and are violating protocols. Now you can do this through kind of a software-defined method as opposed to policies that you expect employees to follow. Now, obviously, big challenges around hardware performance and software availability and how you actually deploy the security solution. And so that's essentially why we started the company Rescale. And what we did with Rescale, our main product is a platform that has many of the features deployed to be able to let our customers take advantage of CAE tools in the cloud. And so a little bit more about Rescale. We started about 4 years ago. We're over 20 people based in San Francisco. We're a venture-backed company. And we started with the thesis around addressing this opportunity. And I'll talk a little bit about how far we've come so far. And we're growing very fast. And so we'd love to talk to you also about specific needs you might have, or if you have interest in this field. Now, the specific problem that we're solving is essentially around a typical engineering organization has different needs over time. And so what you see here is kind of a general chart around as the product development cycle progresses, you have different simulation needs. And so this is just a notional kind of view of a company's demands. But essentially, as you go through preliminary design, final design, and then critical design review, the amount of simulation that's run by engineers changes over time. And so trying to build for that with fixed clusters is very difficult. And there's a lot of IT organizations that are very good at doing this, especially for very large companies, managing hundreds of thousands of employees and thousands of people utilizing these clusters. But no matter what you do, essentially you always have the same problem of varying demand and trying to address it with fixed capacity. And often, for something that lasts maybe 2 or 3 years within your enterprise. And so with cloud, you can essentially meet exactly the demands as they come up. And not only that, you can tailor it to the specific needs within engineering groups. So as you get more granular within all these different applications, there's different hardware that's optimal for different people. And so you can really meet this need over time, and you can help avoid schedule delays. Because essentially what happens, you pick kind of a fixed capacity cluster that you build, and no matter where you choose on this graph, essentially either engineers are waiting or you have a lot of underutilized resources sitting around that are essentially wasted. And especially with new hardware coming online all the time, it's really hard to keep up the pace and keep up with kind of the latest technology. So what we did at Rescale was essentially over the last 3 or 4 years, we've built this global network of hardware providers. And this infrastructure is the largest network in the world of HPC hardware. We have over 8 million servers that you can access directly through our web-based portal. Now, these are all in different global locations. So if you're a defense company inside the US, you're going to be utilizing the ITAR clusters based in the US. If you're a Japanese automotive manufacturer, you're probably going to be utilizing clusters in Tokyo. And what we do is we essentially find the optimal hardware solutions for you as a company, and also for you as an engineer who's actually utilizing and choosing specific configurations on a project-by-project basis. The other benefits that we have is obviously the latest hardware. So staying up with the latest hardware is a critical of critical importance to the organization, right? So essentially, staying on the latest hardware can allow you to run 20 to 30% faster first on a quarterly refresh versus an annual refresh. So what we do, because all these data centers are updating at different times, we provide that to the customers directly. And so by having kind of a global network, you get the benefit, obviously, of instant procurement. And that's huge because most organizations take about 6 months to build a new HPC cluster inside their data center. Some are a lot faster, obviously, but on average, that's how long it takes. So in those 6 months, most of the hardware that you've purchased has already depreciated about 20, 30%. So what we do is help you avoid that kind of delay and that additional cost that your organization is impeding on itself. We also eliminate capital expenditures. You can obviously do all kind of pay-as-you-go. We also have the ability to kind of, for longer-term plans, you get lower pricing, but you have the flexibility to go completely elastic. And that's a lot of organizations are starting with pure overflow and are starting to realize the huge benefits of not having kind of a hard limit on what people have access to. And if you actually look at the total cost of ownership of an on-premise versus cloud clusters, essentially, if you're really calculating what it's costing your whole organization, it's always in favor of cloud. And the reasons are there's huge economies of scale. So you get much better discounts because people are buying these servers in much larger bulk than you are within your own organization. They're much more efficient at how to operate these. They have very robust systems in place. And the other part is that these data centers are all run by very large organizations who essentially have figured out the optimal location of that data center, the optimal way to utilize the power and the cooling. And so you get all that benefit without making any of those upfront investments and all the expertise from all these experts. Now, that gets you so as far as having the hardware. Hardware is just one piece. So you also need the software. And this is another critical element that we've spent many years on procuring this for our customers. And this was a difficult part early on. is that a lot of software vendors, these ISVs in the CAE industry, essentially are starting to deal with, what does it really mean for cloud, right? What does it mean for them? How are they going to be able to operate in the new kind of business dynamic where companies are expecting to be able to turn their software kind of on and off whenever they want? Because when you have flexible, elastic hardware, you also expect to have flexible, elastic software at the same time. You don't have the software component, it can really be a huge detriment to the value you're able to get out of cloud resources. Now, there's also obviously open source and proprietary codes, and that's actually where most of our initial customers, 4 years ago when we didn't have all these partnerships in place, that's where they started. A lot of certain specific, industries like in life sciences, a lot of molecular dynamics codes are open source. So those are a great place to start. But, in industry for CAE, if you're looking at an aerospace company, almost all the codes they rely on are either internal proprietary codes or some of these commercial codes that these vendors provide. And so what we've done is kind of come up with a business model that works well for them and works well for the customer. And what this is typically on-demand pricing at an hourly rate at a premium over kind of the prorated monthly or annual, whatever the standard package is that you purchase. A good example of this is Siemens, where we have NX Nastran, a popular FEA package. This is available hourly, and they even have a discount if you're running hundreds of licenses at the same time. And that is for those customers who are essentially running very large designs of experiment where they're trying to compare thousands of different models at the same time, and they need licenses for that. But they only need licenses for the 10 hours that simulation takes. They don't want to purchase annual licenses for 100 seats. So another great partner on the CFD side is Converge, Convergent Science. So this is kind of a niche tool used heavily in internal combustion engine development. And they also have an hourly rate, and this scales with the number of cores you're utilizing. And so very quickly, you're seeing many of these software vendors, and we now have hourly rates for over 10 of these vendors, and we'll have many more coming soon this year. And what it really means for you as a customer is that now all of a sudden you can kind of procure the hardware and the software you need all at the same time, and you can make an easy decision from a budget point of view. Hey, does it make sense for us to run this set of simulations? You have a specific price that it will cost you, and you can make a decision on that if it's worthwhile. And for 99% of the cases, customers are seeing, hey, now all of a sudden I can purchase so much more simulation software because I don't have to make this kind of conservative assumption on how much am I going to utilize this license in the future. So by getting it on demand, it's a huge benefit for both the software vendor and also obviously the customer. The other critical part is security. So what we've built is a stack of technologies to essentially end-to-end encrypt all the data that you're utilizing. Our first customers were in the space industry, and so we had to build the first deployment in an ITAR secure environment and following all the SOC 2 compliance rules and the ISO certification. And so this has taken a lot of technology development to execute on this, but essentially it's possible to keep your data encrypted throughout the entire process except when you're running your simulations. When you're running your simulations, these clusters can be isolated, and that customer is the only customer that has access to it, and sometimes it's isolated from everybody. And so what that means is, there's no external access while the simulation is running. It gets completed, encrypted, and passed back down. The encryption keys are fully in control by the user or the enterprise that controls that user. And so this is something that has been fully certified, audited by many Fortune 500 enterprises over the last few years, and it's really possible. So I know there's a lot of skeptics out there of can you really deliver the same security level that we have on premise. I would venture to say that we actually can deliver a better security on our system than a lot of people have on premise, and the reason is because of the software-defined controls and software-defined security around who gets to look at what data at what time. So within an organization, for example, an aerospace company, you can have groups of users who are ITAR and compliant and who have access to ITAR, and groups of users who don't. You can programmatically set up a way that these cannot share data with each other and ensure that. And the other alternative, how it often happens today, is you just trust the employee who downloads it on a USB key not to pass that data along. And so for cloud, it really changes the paradigm. Yes, you have to address all these security concerns and address it head on, but it can actually provide for the IT organization huge benefits. So the other final part is kind of the platform. And so what this is, and what you really need is kind of a platform solution that makes it easy for both the engineers and the users to essentially access these resources, deploy their software, run their models, collaborate with their team, do things like remote visualization if they don't want to download terabytes of data that they've ran. And you also need the IT side. And on the IT side, what we have is essentially this way for the IT organization to fully control all the user groups, the way data is shared, like I mentioned, for security, but also a direct tap into your scheduler. So if you're an on-premise system with a scheduler, you can just tap that right into Rescale's network and start submitting jobs there when you need overflow. You also have a set of developer tools available to you to be able to do things like sync all the data you have on Rescale for your users, sync it locally overnight every day. We have customers who do that, and terabytes and terabytes of data. So there's many opportunities here, but you do have to deploy it the right way. So finally, I'll show you kind of a quick demo. I think we have time. Yep. So quick demo here of how easy it really is to run on something like Rescale or other cloud platforms. So essentially, let's see here. Okay, so to log into Rescale, all you do is just open up a web browser, go to platform.rescale.com. I'm already signed in, so just going to load my interface. And the first thing you'll see is kind of this jobs interface. So you have all your simulation jobs right here in the interface, and every engineer sees the jobs that they own and also the ones that are shared with them. So one of the big benefits of deploying this through a web portal or a cloud-based system is that sharing of data is instant. So you can share 100 terabytes of data instantly between two users. And the reason is this is just done through security protocols, and you don't actually have to move the data. You're both accessing the same source of data, and you're just allowing access to another collaborator. Obviously, within the enterprise, this is highly controlled, and only users who have the ability to share within their group are able to share with each other. So what I'll do is I'll quickly walk through a simple job setup. And I don't have a lot of time, but you'll see how easy this is. It literally only takes a few minutes. So first, once you set up a new job, essentially you start with an input file. You upload this from your desktop, or you can upload it from Rescale storage. So if you've uploaded a lot of data, you actually never have to keep uploading it again and again. You have this storage, essentially an entire files-based system on the cloud that you can access anytime. So if you have large loads files, which is common in aerospace or automotive, that you use all the time, you just have those right up there. You don't have to keep copying it. You just have a single store, and you have references to that store of data. Then you can do different types of jobs. So you can basic designs of experiment, optimizations, these kind of workflow elements which are critical for an engineer. And in this case, we have a design of experiments of a Nastran beam analysis. And so here's some parallel settings. So these are just variables defined directly in the browser, and you can do more complicated programmatic definition of these. You can upload a CSV file which has all your parameters predefined, or you can just define them right here in the interface. Then you have templates, which are essentially the input files, which are templated where all these values are being populated. You select your software. In this case, we have NX Nastran selected, and we're going to purchase a license. And in this case, we can do this on an hourly basis. Put a credit card down, we can get up and running. Now, the hourly licenses are a great component of this kind of platform, but you can also just bring your own license. So if you have a lot of licenses in-house, you can utilize all these same licenses on Rescale. All we do is just set up a port to the license server you have in-house. We can do that securely, and then you can utilize your existing licenses on much more optimal, the latest hardware versus what you might have on-premise. Next, you define your hardware here. And so in this case, I've defined a core type, the nickel core type. It's pretty popular. You just define a number of cores. And this is really deceptively simple here. You can just keep scaling this thing up and to as many cores as you want. And we have customers who run tens of thousands of cores in a single job in one time. And so you really have essentially virtually unlimited capacity available at any time at your fingertips. This is great for organizations who have those critical timelines. A bad test comes back on the engineering side. You want to rerun a bunch of simulation, you can do that immediately. There's no IT headaches to be able to try to provide for that. The number of task slots. So this is basically for design of experiments. How many slots do you want for each of these simulations to run? So we'll just run 2. And that's literally how easy it is. All you need is an input file, your software, and your hardware. These other settings are all kind of optional. And then you just go and submit the job. And so what happens now is essentially the job gets queued up inside the Rescale system. But because we're running on demand, the queuing is essentially instant, because now you're going to start validating the input and start the cluster immediately, because the on-demand hardware is always available. You also have options to kind of run on prepaid clusters, and these are at a lower price point. So if you have a lot more predictability in your engineering needs or your HPC needs, essentially you can get lower price points. But for unpredictable uses or just regular everyday use, if you're not super price sensitive, this is a great option. And so here, cluster starts. It's going to take a couple minutes. We can come back to it. But I'm just switching over here to a job I started just a few minutes ago. And as the job is running, essentially what you can do here is look at output files as this is running. So I can go look at an output log file, and I can tail any of the files here. I could do a remote desktop session if I have a user interface I want to utilize. You can essentially do anything. Take a snapshot of all the data, whatever you want to do. And then, as the results start coming in, you can already start manipulating these. This entire job can be shared with other users at the same time while the job is running. And this type of analysis can be, very powerful right in the browser. Obviously, a lot of people utilize their existing kind of user interfaces for their software packages. But you can also, when you start running tens of thousands of simulations at the same time, you want to kind of manipulate this data. It's helpful to kind of do a quick scatter plot and maybe look at a design point that's interesting to you. You can click right on that, get that design point right here in the interface. And then if you want to do, in the case of an optimization, response surfaces are probably more helpful. And so you can, plot your own response surface and rotate that around, take a look at what makes sense. But essentially, that's how easy it is. So now I'll just skip back here to the presentation. So who's really doing this today? I think people underestimate how many companies are already utilizing cloud. I think on one of the early slides I talked about, it's on the slide, I didn't talk about it, is that 97% of all Fortune 500s are already using cloud in some kind of way. And obviously engineering and scientific data, is very sensitive to corporate enterprises, but deploying it this way is actually the most secure way to utilize these cloud resources. And it's much better to do it in a very secure way than have an engineer kind of go rogue and start deploying stuff themselves on Amazon or something like that. It's better to kind of attack this problem head on and provide these resources than have people, put their sensitive data in kind of unsecure environments. So here's an example of in the aerospace industry, some of the customers, obviously space is a great area. There's a lot of NASA codes that are essentially open source. They're ITAR controlled, but open source for companies to use. So we have many companies that are kind of in the private space and ancillary kind of sectors that are doing this. Automotive suppliers, it's huge because for automotive suppliers, essentially, they get project by project basis kind of work. And they've always had this issue of trying to kind of predict how many licenses, what type of cluster to buy. And now they can just do it on a project basis, and it works out great for them. Oil and gas, so you have kind of the CAE tools that are used to develop drilling equipment, but then also you have reservoir simulation. And so a lot of people utilize it for scaling out large reservoir simulations, run a big simulation. They might only run once every few months. Now they don't have to build a big custom cluster for that. They can just do that right there in the browser. some more fun customers like Formula One teams who are optimizing their designs. They're really on the cutting edge of how you use fluid dynamics, how you do structural runs together with fluid dynamics to do their full optimization. Interesting dynamic there is they have actually pretty strict controls on how many flops they're allowed to run every couple of months. So it's really important that they get the optimal use out of the hardware. And so cloud is actually a great way for them to get the optimal hardware at any point in time. And they do a new kind of tweaks to the car every couple of weeks when they have a new race. Global, Fortune 500, Aerospace, it's a great application for that. There's obviously the ITAR side, there's also the commercial side. There's many different companies who are starting to experiment with this, and many who are starting to deploy it and have already made the decision that an on-premise HPC is much more costly than starting to deploy directly in cloud. And especially with the pressure on IT budgets, this is a great way to address that. There are large industrials, obviously, as well. Obviously, this is kind of, for Siemens, this kind of windmill structure, it's almost the same thing as a composite wing on an airplane. So very similar types of analysis and similar types of challenges. So how do you do this in a socially responsible way? I would say just use the cloud, because essentially by default, you will be utilizing the most efficient assets, because we're going to direct you towards the most efficient resources where data centers have the cheapest per hour rates. And so you can go there to essentially utilize in the most cost efficient and resource efficient way. You're also sharing a pool of hardware with other companies. And so it's not just efficient from that perspective, from a global perspective and a macro perspective. There's a lot less free capacity sitting around when you share this between companies. And sharing it between companies, you're still doing this in a highly secure way. You're just segmenting off different components of that data center. So finally, just to reiterate, in the industry, we're seeing a huge move towards cloud. And the reason is you can just develop better products faster. People are seeing this in small projects, big projects, long-term investments. And it's really driving the next generation for all these companies in these sectors. Next generation products, all the leading companies are essentially starting to, at a minimum, experiment with cloud for their most kind of hardware sensitive projects where they have huge simulations they want to run. A lot of these are just not financially feasible or even feasible technically without deploying it on a cloud infrastructure. And then, what I would say is that at Rescale, we have the best solution for you. We've, over the last years, built ourselves to be the global leader in this space. We have the most hardware, we have the most software, and we have a ton of experience deploying this with Fortune 500 organizations and global organizations that are utilizing this in Japan and Europe and in North America, and defense companies in North America as well. Final note, if you're worried about, this is Silicon Valley and startups, go up and down all the time. We have a base of some great investors. So we do have Jeff Bezos, Peter Thiel, Richard Branson as investors as well. So financial stability for us is not an issue. All right, that's it. I'd love to answer any questions you guys might have. And we also have Xing in the back there, who has a $50 coupon for attending the conference that you can use on Rescale today. There's no cost to signing up for an account, and go try it out yourself.